This is our safety valve calibration table. We can see it from top to bottom. We will explain in sequence. It is now a pressure gauge for each range separately. Is to use two. The reason is because, when preventing, to prevent damage to one of the pressure gauges simultaneously. Here's another gauge. You can see that the other one is damaged. For example, what we charge. If the pressure we charge here is 10 trillion, our watch shows 12 trillion. This table shows 10 trillion. That means the watch is broken. We can see the following three needle valves. It's the pressure gauge switches we correspond to in turn. Just open whichever you use. When we use sorghum with low range, you can also open the sorghum journey. But when using sorghum, can't you turn on the low range one? It is worth noting that, like when using 1.60 trillion pressure gauge. Talk about that later. This is our water pump pressure gauge. Water pump pressure gauge. This is our air pump pressure gauge. When there is a gas cylinder inside, when opening the gas cylinder, the pressure shown on this pressure gauge is the pressure of the gas cylinder. When closing the gas cylinder, yes, the pressure on this, it's the medium we're putting in, the gas pressure. Our safety valve can achieve. Oxygen or nitrogen can be added. This is our Titan pressure gauge. This is our Titan pressure regulator. Screw to the left to decompress. Screw to the right to boost the pressure. This is our low voltage calibration switch. Our low voltage calibration switches. There is a low pressure regulator on the front. It's been adjusted to 1.20 trillion. When we use this pair of tables, turn on its pressure gauge switch. Turn on the low voltage calibration switch again. This is the maximum pressure indicated on this pressure gauge. It's 1.20 trillion. This low voltage calibration switch, used only when using 1.60 trillion pressure gauge. Then use 16 or a 60 megapascal pressure gauge, is to use high pressure or medium pressure. The check switch is this. And this is our unloading valve. We need to turn off the out of effect switch when we unload. Then open the unloading. When the pressure gauge shows 0, we can loosen the clip table. Let's take a look. The function of the needle valve on the side of the clip table. This is a clamping valve. When we have the pressure regulator there, after adjusting the pressure to the appropriate pressure, open the clamping valve first. Pull this reset valve down. Then close this unloading valve. This is a clamping pressure relief valve. Close this valve. Open this clamping valve. Then this pressure will rise. Step up and the platform will go up. This is our drain valve. The drain valve is installed at the bottom. When we test with liquids, test with a pump. When unloading, open this drain valve first. Drain all the water inside. Then open the unloading valve again. Is this the whole unloading process? Okay, let's take a look at the next video. Branded. This is the first video 21 action. Okay, let's take a look. The clamping process and release process of our safety valves. We will first clamp the pressure regulator. Adjust the pressure to the appropriate pressure. I'm now adjusting the pressure to about 2.30 trillion par. This has a clamping force correspondence table. We can set the pressure according to the reference table. It doesn't matter how high you can set it. Then let's look at our clamping process first. This is our matching center mat. Let's put that aside. Let's look at the clamping process first. Close this clamping unloading valve. Press down this reset hand pull valve. Clamp this valve. Open the clamping needle valve. It will rise. You can see it's gone up. To relax, close the clamping valve. Open the unloading valve. Then pull the reset switch. It will go down. You can see it. Okay, we'll clamp the safety valve now. Place the center pad in the center position. Clamp and put the safety valve on. Then push the cords into place. Then you can step up. The steps are the same. Step up. Okay, it's clamped. The remaining valves can be closed. Okay, adjust the pressure slowly. Okay, the setting pressure of our valve, about 1.44 trillion. We use 1.44 trillion. Very close to the full scale of this watch. So that's it. We choose a high range pressure gauge. So let's go with this 16 megapascals. Turn on the pressure gauge switch of 16 megapascals. Why did you choose this? After selecting the appropriate pressure gauge, when inspecting the safety valve, its setting pressure, that's the jump pressure, do not exceed 2/3 of the scale of the third meter of the table. If it is to inspect several valves, it can be compared, can exceed 2/3 of it. But try not to overdo it. Otherwise, due to the number of users, purchased almost full scale, too many times, he knows the pressure gauge will be inaccurate. For example, non-return to zero boost. The hands of this pressure gauge do not match the actual pressure. This is all. This is what happens. Okay, Okay, and then we'll come back to the program later. We don't need to use the program yet, like to operate this needle valve interface. Let's take a look at how the gas teeth are. That one uses a shut-off calibration valve. Then we have this low-voltage check switch. I said in the last video, he can only go to 1.20 trillion. But our actual use of pressure here, 1.40 trillion up. So we use high-pressure check switch, and that's when we slowly open it up. Our high-voltage verification open view. Look at the reading on the pressure gauge. We'll look at that program. So this is our actual pressure. We choose our sensor here. 0 to 16 trillion. You can look at the pressure on the screen. Look at the pressure gauge. Then slowly open our high and medium voltage calibration switch. Okay, the pressure is building. See, the pressure on the gauge is rising. It's gone up here. We slowly boost the pressure. Okay, you can see that I turned off the high pressure. I turn off the smoke switch. As soon as you die, the pressure here drops sharply. It also proves that after we reach the pressure just now, the safety valve is open, so there's a pressure drop. Then unload. You can see the pressure on our pressure gauge. I'm going to turn this high voltage switch off. Then open the unloading valve. You can see that the pressure above us has stopped. As you can see, it slowly descends. Close the pressure relief valve until it returns to zero. This is our entire pressurization process. Well, let's take a look. How is our low voltage calibration switch pressurized? Okay, I have this pressure reducing valve now, and high and medium voltage calibration switch off. Turn on our low voltage calibration switch. It can only go up to 0.1 tampa. You can take a look. I'll open it now. You can see the readings on our pressure gauge. Let me open it up completely. You can see that its highest pressure is 1.12 trillion. We can adjust the pressure regulating valve at the back, but the maximum voltage regulation is adjusted to 1.60 trillion pa. And you see, I opened it up completely. It doesn't boost either. This is our low voltage calibration switch. How is it used? The same goes for unloading. Turn it off. Then open the unloading valve. The value on the pressure gauge. Just return it to 0. Okay, wait a minute, 321 starts. Let's take a look at the whole process of gas calibration. We're going to start by setting up some of our experiments with some valve information. In this upper left corner, here's an experimental setup. One click, here's an experimental message. You can see it. Here it is. You can enter some of our valve information. For example, the diameter number of the valve, and the stress of our work, setting pressure. What is the medium? All can be set here. And there's a check number. We are doing well, our program is divided into one adjustment and triple check. That is, after one tuning and 3 checks are completed, I want to cut a valve. We're going to click on an odd number first. We'll manually number it yourself. It's all okay. Then we pull down. There's a requirement here to set the pressure. The required setting pressure for our valve is 1.44 trillion pa. We enter 1.44. and 1.44 here. The remaining valve information is no longer set. Yes. Go back and type it yourself. You can take a closer look. You see the recipient. Principle. The inspection date can be set. Then visual inspection. Which one fails the disassembly inspection? You can also set it here. Then after the setting is completed, scroll down and click this to confirm the input. You can see it. The required setting pressure here is 1.44 trillion. This decimal place can choose 2 decimal places, or more precise 3 digits. Let's choose 3 first. Then, this allowable deviation, that's our actual setting pressure. Error range with our required setting pressure. Let's set it at 5%. Okay, then our seal holding time. Well, normally, it's about that. That is almost always checked and held for 60 seconds. And now we have this whole experiment. We'll hold the pressure for 5 seconds. Let's do the experiment for a moment. So our holding time is short. Then the whole material can be carried out now. We'll do the whole thing first, and then the validation pattern. The difference between the single-step mode and the continuous mode is, continuous mode is a. You are used to that. Very skilled. Yes, the whole process is under control. Just choose continuous, single-step mode. Every time you do it, this buzzer always goes off once. Then you have to click it again to use it. We're going to go for continuum here. Then choose our sensor range. It's a 16 megapascal gauge. Just choose a pressure sensor of 16 megapascals. Okay, then let's do the tuning first. Tuning means taking off the safety valve. It's over. The verification process is more troublesome. Tuning is just one. Then we turn on the pressure gauge switch. Just open our high and medium pressure calibration valve. Then open it. Open slowly. Don't open it too fast. Okay. It ends today. You can see ours. Click to confirm. This is the actual setting pressure. Current setting pressure. The green one is something we can change. You see its actual setting pressure is 1.455 trillion. Then after the tuning is completed, unload first and close it. Unload first. Okay, when the gauge is almost 0, then close it. Then click verify. Okay. You can see them all here. Then this is every one of our reminders. Operation stats. Then turn on the salt and pepper switch. Okay. Then unload. Open unloading valve. Unloading is not full unloading. It is unloaded to 70% of the setting pressure. Then remind the boost again. Boost is later. Press to 90% of the setting pressure. Pay attention when boosting. Do not exceed the value prompted by others. Otherwise, the seal pressure cannot be maintained. You can keep it now. Good looking. Pressure drop within 5 seconds. This is the real-time voltage drop displayed. Okay. Then unload again. Can be unloaded to 890 billion in advance. Okay, up to 1 megapascal again. Okay, close. And then the third time. His steps are the same 3 times. Display the bar according to the status below. Just operate it. Then after the third sealing and pressure holding is completed, the system can be unloaded as a whole. Okay, so our entire gas calibration is complete. If the setting fails, there is no need for verification. When will the setting pass the verification? Then click Experiment and switch on this interface and click Query here. You can check our report just now. Click the Query Historical Data. This click queries the historical data. Is to check this time period or reports up to this time period. Changes can also be made. We won't change it here. We can just click to inquire. Okay, so that's what we just did. Then click Generate Teaching and Research Record. Okay, here you can choose Teaching and Research Records and Teaching and Research Reports. Two forms. And let's look at the record first. This is what we just did. Actual pressure curve. Then look at the record. Inside. Let's take a look at the report first. Okay, let's close it.